In the final video of this section, we're going to look at solving an equation with extraneous solutions. In the example below, it says solve 1 divided by x minus 2 equals 3 divided by x plus 2 minus 6x divided by x minus 2 times x plus 2. Now, notice the difference between this example and the previous one. Here we have variables in the denominator, whereas in the previous example, we didn't have that situation. We only had variables in the numerator. So we have to just pay attention right from the start that there are going to be restrictions on possible solutions. So for instance, we could see that this first fraction right here to the left, we cannot have a solution where x is equal to 2. And the reason we cannot have a solution where x is equal to 2 is because that would give us a scenario where we have a fraction of 1 over 2 minus 2, which would be 1 over 0, which is undefined. That's not possible. In this second fraction, we have a situation where x cannot be equal to negative 2. Because, again, we'll have a fraction where our denominator is equal to 0 again, and that would be undefined. And in the third fraction, it consists of both of those scenarios. So we have to be aware that once we solve this equation, if one of our solutions or both of our solutions are either 2 or negative 2, we're going to have to throw those out. Those are going to be considered extraneous solutions. So let's go ahead and solve this. And just in like the last example where we're solving a rational equation, we multiplied both sides by both denominators. We are going to multiply both sides by both denominators again. Okay, here we have a denominator of x minus 2 and a denominator of x plus 2. And the third fraction, notice that that denominator is x minus 2 and x plus 2. So we don't have to repeat this process for that fraction. So I'm going to go ahead and expand this. So this becomes x minus 2 times x plus 2 equals 3 over x plus 2 times x minus 2 times x plus 2 minus 6x over x minus 2 times x plus 2 times x minus 2 times x plus 2. So notice we're multiplying every single term by x minus 2 times x plus 2. And now we could go ahead and simplify just like we did the last time. It just looks a little bit more complicated because we're dealing with quantities with two terms. So there our x minus 2 cancel out, and we're left with 1 times x plus 2, which is just x plus 2. I'm dropping the parentheses because we no longer need them. We're not showing any multiplication. The next term, we have x plus 2's get simplified out, and we're left with 3 times x minus 2 minus, and then our last fraction, our x minus 2 simplify out, our x plus 2 simplify out, and we're just left with 6x. So now we're looking at a much simpler looking equation without any fractions, and we're going to go ahead and solve that the way we had in the first video. So we're going to distribute. So my left side stays the same. My right side becomes 3x minus 6 minus 6x. Then we're going to combine like terms where we are. Again, my left side stays the same. I can simplify this. 3x minus 6x is negative 3x. Now I'm going to get all of my x terms to one side. So I'm going to get all my x terms to the left side. So I'm adding 3x to the right, adding 3x to the left. That becomes 4x. So now I'm going to subtract 2 on the left side to get my 4x alone. And now finally, 4 times x, I'm going to undo that by division. So we have x is equal to, excuse me, negative 4. And, oh, excuse me. Let me back up there. I made a blatant mistake. I divided both sides by 2 and should have divided both sides by 4. Divide by 4, divide by 4, and we have x is equal to -2. There we go. That's looking better. But now we have x is equal to -2. That is our solution, but we have already said up here that x cannot be -2 because it makes one of our denominators 0. So this we have to throw out. That is our extraneous solution, and we don't have another solution to choose. So in this particular case, we don't have a solution, so we're going to say that there is no solution to this particular equation. This particular equation is actually a contradiction when we get right down to it.